Hello everyone, this recording is for Pre-Algebra Chapter 6, Lesson 1, Ratios and Unit Rates. But first, a quote from Ronald Reagan, former President Ronald Reagan. "Freedom is never more than one generation away from extinction. We didn't pass it to our children in the bloodstream. It must be fought for, protected, and handed on for them to do the same." Alright, ratios, unit rates. A ratio is a comparison of two quantities by division. There are three ways to show a ratio: 10 to 15, 10 to 15, and 10 over 15. Alright, so the first way is obviously using the word 2. You can use a colon or a fraction bar / division bar. Alright, a rate is a rate is a ratio that compares quantities in different units, much like dimensional analysis and unit analysis, which we'll talk about later in this lesson. I hope you guys remember it. If not, you're going to get another crash course in it. A unit rate is a rate that has a denominator of 1. Examples of unit rates are cost per item, miles per gallon, and miles per hour. So, rate would be like a cooking recipe. So if you were to double a recipe, it would be like, or even triple, if it's 5 cups of flour to 2 cups of water. If I were to increase this and still keep the same rate, I could do 10 cups of flour and 4 cups of water. Alright, so this rate allows you to tell you the most basic form of what's going on, so that even if you double or triple something, you'll be able to figure out what it is by then just multiplying by 2 or 3 or 4. And the rate stays the same, it's just you're making a bigger batch. So rates are really good for cooking recipes, especially if you helped anybody cook and you've doubled or tripled recipes. It's very important to understand the rate of what's going on. Alright, and then unit rates, so we can have cost per item. Let's say it's 55 cents per potato. It's 15 miles to the gallon, which means you can go 15 miles on 1 gallon. So if you only had like 1 gallon in your car, and your car got 15 miles to the gallon, you can only travel 15 miles before you're going to run out of gas. And then the same is for a unit rate when you're talking about speed. If you're going at 65 miles per hour, after 1 hour you'll have traveled 65 miles. Make sense? So those are unit rates and rates in your everyday life. Alright, so which size has the lowest unit cost? Unit cost is how much you pay per item or per amount of something. And when you're at the grocery store, or at some type of big, like Costco or Food for Less or whatever, and you're buying food or you're buying an item, the size of the item and how much that item costs can then determine which one you might want to buy. Alright, and you can figure this out using the unit cost. Now, a lot of stores that you go to will actually have this printed on the label. It'll say how much each smaller unit inside, how much the volume is, the individual volume unit is. So if you're buying like a liquid and you're like, alright, this one has 25 ounces and this one has 30 ounces, and the 30 ounce item costs a little bit more, but it might also be because you're also buying more ounces, not necessarily because what you're paying per ounce is actually more. So we're going to take a look at this right now. So, to find the lowest unit cost of these particular things down here, unless we can say this is like dish soap dish soap. We can have a trial dish soap, regular dish soap family, or economy. And we want to know which one's cheaper per unit. Because yes, we're buying maybe more than we needed right at the time, but since dish soap really doesn't go bad, or you'll use it, within a certain amount of time, it's obviously not going to go bad. Sometimes it's more economical to buy something bigger, because even though you might be paying slightly more, it's going to last longer, and you are technically paying less per ounce. Alright, so to figure out the lowest unit cost, we're going to divide the total cost or price, by the number of ounces, or the volume that you have. Alright, and then the cheapest cost per ounce will be the lowest unit costs. So let's go ahead and do some division. We're going to take the price of the trial size and divide it by the number of ounces. So it'd be 0.78, which is 78 cents, divided by 6 ounces is going to be 13 cents per ounce. So for every ounce, you'd be like shilling out like 13 cents. So like if you went to like, never mind, I'm not going to get into that. You guys understand that each ounce in this trial size container would be the equivalent of 13 cents if you were to only buy it by the ounce. Whereas the regular size, which is $1.20 per bottle, which has 12 ounces in it, we're going to take the $1.20 and divide by 12, and it's 10 cents per ounce. So this is noticeably different. The regular size is 3 cents cheaper per ounce than the trial size. Let's go ahead and look at the family. The family is 224 divided by 28, which is 8 cents per ounce. So that's 5 cents cheaper than the trial size and 2 cents cheaper than the regular size. So far, the family size is definitely the cheaper value, and that means you're going to pay less per ounce. Let's go ahead and look at economy. Sometimes economy means cheap, and sometimes economy just means more. So let's figure out if we're just getting more in the container or if we're actually paying less for what's in the container. So, $3.60 divided by 40 is 9 cents per ounce. So that means that the family size container is actually the cheaper value, that you're going to pay less for what's actually inside there. All right. So there you go. And then again, this is really important if you're like having to do groceries or any other type of items on a budget. So it's something you should know how to do. It's a lot of things parents do when they're at the grocery store or buying things in bulk. All right. So next thing we need to talk about is a car goes 425 miles on 12.5 gallons of gas. What is the unit rate? And this is basically figuring out mileage. The more miles you can go on 1 gallon of gas means you don't have to stop to buy gas as often, and buying gas can be expensive, and it's also better for the environment because if you're using less gallons of gas, you don't have to pull as many out of the ground, blah, blah, blah. I'm sure you got that. All right, so how many miles can we go on 1 gallon of gas? That is the unit rate. So we're going to take the number of miles and divide by the number of gallons, and that, again, is going to give you the number of miles traveled on 1 gallon of gas. So that would be 34, handy dandy calculator, 34 miles to the gallon, which means if you had technically only 1 gallon of gas in your car, you could go 34 miles without running out of gas. But eventually, obviously, you are, because there's only 1 gallon of gas in your car. All right. And that compared to the example earlier, it's definitely much better fuel economy. All right. So let's talk about dimensional analysis. I got 2 examples for you. Hopefully you'll remember how to do this, and if not, you'll learn it now, because it is a little tricky, but you guys got to start getting really good at this. All right, so turtle swims at a rate of 10 miles per hour. How many feet will it swim in 5 minutes? Well, first thing we're going to do is figure out how many feet it can swim in an hour and how many feet in a minute it can swim, and then we're going to multiply it by 5 to figure out how many feet it swam in 5 minutes. All right, so we have 10 miles per hour. Remember, the word per means like fraction bar and division. All right, so 10 miles per hour. So we're going to multiply it by the number of feet there are in a mile, which is 5,280. And remember, I put similar units diagonal from each other, because they're going to end up canceling out. Miles over miles equals 1, cancels out. All right, so this is a unit rate because I'm comparing the number of feet to 1 mile. And if you go back to the definition on the very first slide, remember that unit rate is comparing 2 different units, where one of the units, in this case the denominator, but it can also be the numerator because it is a comparison, is 1. So 1 mile. All right, so then we also have 1 hour is equal to 60 minutes. Again, see how the similar units are diagonal from each other. Okay, and that's because we want them to cancel out. So, again, another unit rate because we're comparing 2 units where one of the unit is equal to 1. The hours are going to cancel out, and the miles are going to cancel out, leaving me feet per minute. And remember, because the feet is separated from the minute by a fraction bar, that's the word per right there. All right, so we have 10 times 5,280 times 1. And again, we will multiply by 5 once we get there. So that's, that's supposed to have an extra 0 in there. And I don't know if when I did my math earlier, if I actually got that in there. So 52,800 divided by 60 is not 88. It's 880. There we go, which means when I multiplied by 5, it is actually not 440. it is, let's multiply that by 5. I love it when I catch my mistakes. It is going to be 4,400 feet in 5 minutes. All right? So there we go. I must have forgot to multiply by 10 miles up there. All right, so this is a pretty fast turtle. This turtle can swim can swim just under a mile in 5 minutes. They must not be fast on land, but they're definitely fast in water. Okay, well, if they're swimming 10 miles an hour, that's actually pretty fast. All right, so there you go. All right, so again, remember when we're doing dimensional analysis, we put the units that are similar diagonal from each other. So if you don't put them diagonal, they'll never cancel out. And we don't want miles in our answer. We wanted feet in our answer. We also didn't want hours in our answer. We wanted minutes. So we have to put the things that we don't want anymore in there diagonal from each other so that they will cancel out. All right, so here is another dimensional analysis problem. We have 3.5 quarts per minute, and we want to figure out how many gallons per hour that is. And just so you know, there's 4 quarts for every 1 gallon. So let's go ahead and set this up. We have 3.5 quarts per minute, and we're going to multiply by 1 gallon over 4 quarts. And again, this is in unit rate. And again, I put the quarts diagonal from each other so that they will cancel out. See, they're diagonal from each other. And I'm also putting the minutes diagonal from each other so that they will cancel out as well. And there's, again, 60 minutes in an hour. I hope you all know that. All right, unit rate. And now just think of it as multiplying big, giant fractions. Big, giant fractions. So we have 3.5 quarts times 1 gallon times 60 minutes because they're multiplying all of the numerators. Now, if I multiply all the denominators, I have 1 minute times 4 quarts times 1 hour. And again, what I have on the top that matches what I have on the bottom, I can cancel out. So I can cancel out the quarts and I can cancel out the minutes, leaving me gallons and hours, which is what I wanted my final answer to be. So then if I multiply the top, I'm going to get 210, because 3.5 times 1 times 60 is 210 gallons. And again, I'm sticking with the unit I have left on the top. And 1 times 4 times 1, sticking with the unit I have left, is 4 hours. So I have 210 gallons in 4 hours. But I really want to know how many gallons per hour in 1 hour. So if I divide, I'm going to get 52.5 gallons in 1 hour. All right? Pretty easy. All right. Last thing I need to talk about is what we call person days. And these will show up every once in a while on standardized tests. And it's something you need to understand. So person days are a measure of the amount of time needed for a number of people to complete a job. So if 2 people working for 1 day can complete a job, then it takes 2 people times 1 day, which is 2 person days, to complete the job. So for the same job, how many days will it take 1 person to complete that job? Well, 1 person times how many days equals 2 person days? Well, it's going to take 2 days because 1 times 2 is 2. So it's a very simple relationship. It's the number of people times the number of days equals the number of person days. And then what you can do is change the number of days or change the number of people to figure out how many of the other thing you actually need. So we have a well, it's supposed to be contractor, not constructor. So a contractor has a job that requires 540 person days. All right. So it can take 1 person for 540 days to do this job, or it can take 540 people 1 day to do this job. But we don't normally have 540 people working on 1 job, and we normally don't have 1 person to take 540 days to do 1 job. We normally have something in between. So we want to know how many workers are needed to complete the job in 60 days. So we don't know how many people we need, right? We don't know how many people. But we know that we want 60 days to complete a 540 person day job. All right? So we're going to divide by 60 days so that we can get our unknown by ourselves, right? You can just imagine that's like an X or an N or an M. And we're going to divide by 60 days on both sides. The 60 days on the left are going to cancel out, and the days on the right are going to cancel out, leaving me how many people I need, which is 9 people. So if we want the job to only take 60 days of work, we're only going to need 9 people to do it. Now I could change that up and I could say, well, what if I wanted 200, if I wanted, say 18 people to work on it, how many days will it take them? Well, then we'll take 540 person days, divide by 18 people, and it'll tell us how many days it will take. All right? So it's a very simple relationship. The number of people times the number of days equals the number of person days. And normally they'll tell you the number of person days and then expect you to either figure out how many people are needed or how many days are needed. And there will only normally be one variable. All right, I'm done. Sorry this took so long. See you guys later. Bye.